Hi dear student, welcome to our chemistry classes. My name is Chobe sir. Today we are going to discuss about the topics of chemical bonding and molecular structures. So our topics: chemical bonding, and molecular structures. Now first of all, we discuss about the chemical bonding. What is the chemical bonding? It is a type of force of attraction between the atoms of compounds, you can say molecules, which attract to each other. The force of attraction between atoms present in chemical species. Like we have H2O. H2O means water. Water contains two atoms, hydrogen and oxygen. Water contains two atoms, hydrogen and oxygens. Hydrogens and oxygens attract to each other by a force of attraction, and this force of attraction is known as chemical bonding. Next we have NH3. In the molecules of NH3, nitrogen atoms and hydrogen atoms are present, and nitrogen atoms and hydrogen atoms have a force of attraction by which they are bonded with each other, and this force of attraction is known as chemical bonding. Then chemical bonding, the force of attraction between the atoms present in chemical species. About the discussion of chemical bonding, first of all, we discuss about some topics like why chemical bond is formed. Why chemical bond is formed? What is the reason to forming of chemical bond? To achieve the first reason, to achieve noble gas configuration. To achieve noble gas configuration. That is the first reason to forming the chemical bond. And the second reason, to achieve the minimum energy. And the third reason, to achieve maximum stability. So we have three reasons to forming the chemical bond. First of all, achieve noble gas configuration, and second, achieve minimum energy, and third, achieve maximum energy. What is the noble gas configuration? We know that we have 6 elements: helium, neon, argon, krypton, xenon, and radon. Helium, neon, argon, krypton, xenon, and radon. Except helium, because helium have 2 electrons, and neon 8, argon 8, krypton 8, and xenon 8, and radon 8. These elements have 8 electrons in their outermost shells, which is also known as octet rule. So the element which have 8 electrons in their outermost shell, they follow octet rules and they are more stable. You can say they have minimum energy, and whenever atoms have minimum energy, they are more stable. Understand? So there are following 3 reasons to forming the chemical bonds: achieve noble gas configuration, and second, achieve minimum energy, and third, achieve maximum stability. Now we are going to discuss about some terms which are used in the chemical bonding. First of all, we are going to discuss about the valence electrons. Valence electron. All these topics are most important to understanding about the chemical bondings topics and molecular structure chapters. First of all, we are going to discuss about valence electrons. What is the valence electrons? The number of electrons present in outermost shell of atoms. We have any atoms which contains the number of electron in their outermost shell, which is known as valence electron. For example, we have oxygen and atomic number of oxygen is 8. The configuration, we are going to discuss configuration 1s2, 2s2, 2p4. Then that is first 2 electrons contains and second 2 electrons add 2 and 4, 6 electrons. And these 6 electrons is known as valence electrons. So oxygen atoms have 6 electrons in their valence shell. Second examples, we have magnesium. The atomic number of magnesium is 12. Doing electronic configuration 1s2, 2s2, 2p6, 3s2. At the electrons, first cell have 2 electrons, second cells 2, 6 electrons, 2, 6, 8 electrons, and third cells 2 electrons. Thus, magnesium atoms have 2 electrons in their valence shells. That is known as valence electrons. The number of electrons present in their outermost shell of atom. The number of electrons present in outermost shell of atoms is known as valence electrons. So, oxygen have 6 electrons in their valence shell and magnesium have 2 electrons in their valence shell. That is, oxygen's valence electrons 6 and magnesium valence electrons is 2. Octet rules say that the valence electrons acquire 8 electrons. That is, every element must be present 8 electrons in their outermost shell. These electrons obtained by either gain of electron, either donate of electrons, either sharing of electrons, maybe any way. But every element acquire to 8 electrons in their outermost shell, which is known as octet rule. Every element acquire to 8 electrons in their outermost shell, which is known as octet rules. And the following of octet rules to acquire octet stability, every element want to share electrons, want to gain electrons, want to donate electrons, and resultant for chemical bonding. Now we are going to discuss about the some terms, some topics which are also used in the formation of chemical bonds. And we have topics Lewis symbol. Lewis symbol. Lewis symbols is also important terms which are used in the formation of chemical bonding in the representation of valence electrons. What is the Lewis symbols? Lewis is a scientist which proposed some symbol to represent valence electrons. G.L. Lewis proposed some symbol to represent valence electron, which is known as Lewis symbol. For example, we have nitrogen atoms, atomic number 7, configuration 1s2, 2s2, 2p3. First cell electrons, first 2, second 2, 5, 2, 3, 5. Now, nitrogen atoms contains 5 electrons in their valence shell, that is valence electron of nitrogen is 5. Then we represent, according to Lewis symbols, the electrons by dot, by 0, by cross. So we represent 1, 2, 3, 4, 5. That is representation is known as Lewis symbols. Next examples, we have Cl17, that is chlorine. Doing electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p5, 2, 2, 4, 6, 10, 2, 12, 5, 17. First cell have 2 electrons, second cell 2, 2, same, then 2 and 6, 8 electrons, 3 cell, third cell, 2 and 5, 7 electrons. That is, chlorine atoms have 7 electrons in their valence shell. That is, the valence electron of chlorine atom is 7. Now, represented symbols. Dot 1, 2, 3, 4, 5, 6, 7. That is known as Lewis symbols. J. Lewis proposed some symbol to represent valence electrons of element which are present in their outermost shell, which is known as Lewis symbols. Lewis symbols are also used in the formation of chemical bond to represent the structure of the molecules. Now, next topic, we are going to discuss about types of chemical bond. Types of chemical bond.
Yep. I did it.
Types of chemical bond. Chemical bonds are following 2 types. The bonds formed between atoms and the bond formed between molecules. First of all, we are going to discuss bond formed between atoms. The bond which are formed between atoms are following 4 types. First, ionic bond or electrovalent bond. Ionic bond here is also known as electrovalent bond. Ionic bond or electrovalent bond. And the second, formed between atoms, covalent bond. And the third, formed between atom, coordinate bond. And the fourth, formed between atoms, metallic bond.
We had it with
Second, bond formed between molecules. The bond formed between molecules are 2 types: hydrogen bonding and van der Waals forces. First, we have hydrogen bonding, and the second is van der Waals forces.
Yes.
There are following 2 types of bond: bond formed between atoms and bond formed between molecules. Between atoms and between molecules. Between atoms, following 4 types of bond is formed: ionic bond or electrovalent bond, second covalent bond, third coordinate bond, and fourth is metallic bond. Bond formed between molecules are following 2 types: hydrogen bonding and van der Waals forces. First of all, we discuss about ionic bond. Or electrovalent bond. In the formation of ionic bond, the complete transfer of electrons is also occurs. Whenever one element gain the electrons and other element donate the electrons, then the resultant bond formation is known as ionic bond or electrovalent bond. For examples, let us consider sodium atoms and chlorine atoms. The atomic number of sodium is 11 and chlorine is 17. Doing electronic configuration, sodium 1s2, 2s2, 2p6, 2p6, 3s1, 2, 2, 4, 6, 10, 1, 11. Now doing electronic configuration of fluorine atoms is 1s2, 2s2, 2p6, 3s2, 3p5. Calculate valence electrons. How can we calculate the valence electron? First cell, 2 electrons contain, second cells, 8 electrons, and the third cells is 1 electrons. That is the valence electrons of sodium atoms. And chlorine atoms, 2 electrons, 8 electrons, and 7 electrons. That is the 7 electrons of valence electron of fluorine atom. So according to octet rules, sodium atom acquires 8 electrons in their outermost shell to follow the octet rules to obtain the minimum energy, to obtain the maximum stability. And like fluorine atoms also acquires 8 electrons in their outermost shell to gain the minimum energy and obtain maximum stability. So sodium atom donate their 1 electrons and fluorine atom accept their 1 electrons. Sodium atom contains 1 electron in their outermost shell, that is the valence electrons represented by cross, and fluorine atoms contain 7 electrons in their outermost shell. Fluorine atom contains 7 electrons in their outermost shell, that is the valence electron represented by cross dot. 1, 2, 3, 4, 5, 6, 7. Sodium atoms donate 1 electrons to chlorine atoms. And the atoms, the element which donate the electrons form positive ions. And the elements which accept the electrons form negative ions. So, sodium atom donate the electrons, therefore it acquires positive ions. And fluorine atoms accept the electrons, therefore it acquires negative ions. That is, the force of attraction occurs between sodium atoms and chlorine atoms. The force of attraction occurs between sodium atom and chlorine atoms. And for NaCl compound which is known as common salt, sodium chloride. Thus, we can say that when complete transfer of electrons occurs between the atom, when complete transfer of electrons occurs between the atoms, then the resultant bond formation is known as ionic bond or electrovalent bond. Next, we have second bond, which is known as covalent bond. Second bond, covalent bond.
Look at got up.
To explain covalent bond, we are going to discuss about the compounds of Cl2, the molecules of Cl2. Cl2 molecules contain 2 atoms of fluorine. First atoms, fluorine, have atomic number 17 and going to configuration 1s2, 2s2, 2p6, 3s2 and 3p5. Calculate valence electrons. First 2, second cell have 2 and 6 electron, 8 and obtain 8 electrons. Third cells contains 2 and 5 electron, 8 and obtain 7 electrons. That is, valence electron of fluorine is 7. We have 2 chlorine atoms. First chlorine atoms here and second chlorine atoms is here. Represented valence electron by Lewis symbol 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6 and 7. Both chlorine atoms have 7 electrons in their outermost shells. To obtain octet rules, required 1 electrons and required also 1 electrons. Thus, these chlorine atoms share 1 electrons of these chlorine atoms, and these chlorine atoms share 1 electron of these chlorine atoms. We can say that these chlorine atoms gain 1 electrons and these chlorine atoms also gain 1 electrons. Thus, 1 electron sharing occurs between both chlorine atoms. And when 1 electron sharing occurs between both chlorine atoms, then they form a single covalent bond. Thus, we can say that define the covalent bond, the bond which is formed by sharing of electron. The bond which is formed by sharing of electrons. In this case, atoms cannot donate the electrons and cannot accept the electrons, but the sharing of electrons occurs between the atoms. So it is known as single covalent bond because sharing of one electrons occurs between the atoms. If sharing of two electrons occurs between the atom, then they form double covalent bond. If sharing of three electrons occurs between the atom, then they form triple covalent bond. Now we consider second examples of covalent bond, and we have compound H2O. Now we are going to discuss H2O. Oxygen atoms have atomic numbers 8, doing configuration 1s2, 2s2, 2p4. Calculate valence electron. First shell have 2 electrons, second shell have both second shell 2 and 4. Add this and obtain 6 electrons. Thus, oxygen atoms have valence electron is 6. And the hydrogen atoms atomic number is 1. So, its configuration is 1s1. That is, hydrogen atoms contain 1 electrons and oxygen atom contains 6 electrons in their valence shell. Represent oxygen atoms here and the hydrogen atoms. 1 oxygen atoms and 2 hydrogen atoms. Both hydrogen atoms have 1 electron represented by cross, and oxygen atoms have 6 electrons represented by dot. Now, hydrogen atoms share 1 electrons from oxygen. These hydrogen atoms also share 1 electron from hydrogens, from oxygen. And these oxygen atoms gain 2 electrons from both hydrogen atoms. Thus, hydrogen and oxygen, 1 electron sharing occurs. Hydrogen and oxygen, 1 electron sharing occurs. And if 1 electron sharing between the atom, then they form single covalent bond. Now, oxygen, hydrogen, hydrogen. And hydrogen and oxygen sharing of single electron, single bond. Hydrogen and oxygen sharing of 1 electron, single electron, that is single bond. That is the example of covalent bond.
I'll argue then.
We have next topic, third bond, which is known as coordinate bond. Coordinate bond is also type of covalent bond. But in this condition, one atom complete share 2 electrons and other atom complete accept the share pair of electrons. For examples, third bond, coordinate bond.
Yeah.
Coordinate bond. And let us consider examples H2SO4, which is also known as sulfuric acid. In the compound of sulfuric acid, we have 3 atoms, hydrogen, sulfur and oxygen. The atomic number of sulfur is 16, oxygen is 8 and hydrogen is 1. Doing configuration of sulfur, 1s2, 2s2, 2p6, 3s2, 3p4. Doing configuration of oxygen, 1s2, 2s2, 2p4. Configuration of hydrogen, 1s1. Now represent sulfur atoms, oxygen atoms. How many? 4. 4 oxygen atoms. And hydrogen atoms is 2. 1 sulfur atoms, 4 oxygen atoms, and 2 hydrogen atoms. Sulfur atoms contain how many electrons? 2, 2, 2, same, second shell, 8 electrons, 3, same, 2, 4, 6 electrons, and oxygen, 2 electrons, same, और यहाँ पर भी 6 electrons. Now sulfur has 6 electrons and oxygen have also 6 electrons. Represent the electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. all oxygen atoms contain 6 electrons in their valence shell, and sulfur atom also contains 6 electrons in their valence shell, but hydrogen atoms contain 1 electron. So hydrogen atoms acquire 2 electrons to obtain to gain stability. So hydrogen atoms have 1 electrons and 1 electrons gain from oxygen. These hydrogen atoms also have 1 electron and 1 electron gain from oxygens. Now oxygen atoms have 1, 2, 3, 4, 6 electrons. So oxygen atoms acquire 8 electrons to gain stability. Now oxygen atoms gain 1 electron from hydrogen and other electrons from sulfur. Like this oxygen also gain first electrons from hydrogen and second electrons from sulfur. And these sulfur atoms contain 1, 2, 3, 4, 5 and 6 electrons. So it is also required 8 electrons to obtain to gain stability. Sulfur atoms gain 1 electron from oxygen and other electrons from other oxygen and obtain 8 electrons, that is stable. These all the oxygen, sulfur and hydrogen become stable due to obtain stability, due to follow the octet rules. Like this oxygen also have 8 electrons, this sulfur also have 8 electrons, this oxygen also have 8 electrons, and hydrogen have 2 electrons, because hydrogen show stability and gain minimum energy in the case of 2 electrons in their outermost shell. But this oxygen have 6 electrons. So this oxygen gain 2 electrons, that is share 2 electrons from sulfur, and this oxygen also share 2 electrons from the sulfur. But in the case of this condition, only oxygen atoms gain the electrons, does not donate the electrons. So the resultant bond is known as coordinate bond. Coordinate bond is represented by arrow. Coordinate bond is represented by arrow. Now draw the structure. Sulfur, oxygen, 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 and 2 hydrogens. Be careful. Oxygen and hydrogen, the sharing of electrons occurs 1 electrons. Oxygen and hydrogen, the sharing of electron occurs 1 electrons. And in between oxygen and sulfur, sharing of electron is 1. And in between oxygen and sulfur, sharing of electron is 1. So form single covalent bond. Whenever the sharing of electrons is 1, then the resultant bond is known as single covalent bond. But in the case of oxygen and this oxygen and sulfur, only 2 electrons gain from the sulfur. So they form coordinate bond which are represented by arrow. That is the coordinate bond. So it is the structure of sulfuric acid, that is H2SO4, which represent coordinate bond. Now we are going to discuss about the next type of chemical bond. And fourth bond is metallic bond. What is the metallic bond? Every metals, let us consider a piece of sodium, and it contains sodium atoms, several sodium atoms, and the force of attraction between these sodium atoms, is known as metallic bond. That is the bond which is formed by attraction between the metals, force of attraction between the metals is known as metallic bond. In the metallic bond, only metals are participated. That is, metallic bond formed between the electropositive element. Because electropositive element is known as metal, and in between the metal, metallic bond is formed. Now we are going to discuss bond formed between the molecules. First of all, we have hydrogen bonding. Bond formed between the molecules, we have hydrogen bonding. hydrogen bonding. What is the hydrogen bonding? Now start the topics. We have HF, hydrogen fluoride, and single HF node. We have many HF. HF, we draw the structure HF, H, single bond, F, H, and F, H and S. Now, discuss about the electronegativity. What is the electronegativity? The tendency to attract the shared pair electrons toward any cells is known as electronegativity. Any atoms have tendency to attract the shared pair electrons because in between a hydrogen and a sulfur, the sharing of electron is also occur. Therefore, they form single covalent bond because sharing of electron occurs. But the shared pair electrons, the electrons which contain in this bond, the shared pair electrons to attract itself toward is known as electronegativity. So we can say that what is electronegativity? The electronegativity of fluorine atom is greater than hydrogen atom and more greater. The electronegativity of fluorine is more greater than hydrogen. So fluorine atom attract the electrons and the atoms which attract the electrons acquire partial negative charge, and the atoms which does not attract the electrons acquire partial positive charge. So this fluorine also contain hydrogen also have partial positive, partial negative, partial positive, partial negative, and partial positive. Thus, fluorine have partial negative and hydrogen have partial positive. The partial positive and partial negative attraction of force of attraction which causes hydrogen bonding. So, due to the force of attraction, and due to the force of attraction between positive and negative and positive and negative. So, we are going to discuss about the hydrogen bonding, the force of attraction between partial positive and partial negative is known as hydrogen bonding and represented by dotted line. Hydrogen bonding is represented by dotted line. In the case of H2O, that is water, also hydrogen bonding are present, which represent the force of attraction between the electropositive, you can say partial positive and partial negative atoms. Fluorine atoms is partial negative and hydrogen atoms is partial positive and causes force of attraction which are represented by dotted line, which are known as hydrogen bonds. Yeah, hydrogen or hydrogen bondings. Okay.
Just